Come on, there we go. All right. So like I said, we're going to be using both the words perpendicular and bisector today. As we talk about angle bisectors and perpendicular bisectors as they relate to triangles. So we want to identify angle and perpendicular bisectors. We're going to talk about the angle and perpendicular bisector theorems, and we're going to use them to find other missing measures and things like that. There's going to be a lot of setting things equal to each other today. So with that, go ahead and if you haven't grabbed your notes already, do so. We're going to get going. All right, so 6.1, angle and perpendicular, and this pen is dying already. Angle and perpendicular bisector theorems. There we go. For those of us that were bothered by the word being a different color, like me, now it's all one color. All right, so it's probably been a while since we talked specifically about perpendicular bisectors, but we've talked about both the word perpendicular and the word bisector. We know what both of those things are. We combine them and define a perpendicular bisector. So a perpendicular bisector is a segment or a line that is perpendicular to a segment and divides it into two equal pieces. Okay, so it's both perpendicular to a segment and divides it into two equal pieces. So what we're thinking about when we see a perpendicular bisector is if I've got a segment, then my perpendicular bisector is going to cut it in half and meet up with it at a 90-degree angle. So this would be the perpendicular bisector. Okay. So there's some convenient things that happen with perpendicular bisectors besides just being a bisector. There's some other convenient things that happen that we're going to take a look at using something called the perpendicular bisector theorem and the converse of the perpendicular bisector theorem. So the perpendicular bisector theorem if a point is on the perpendicular bisector, and I'm just going to abbreviate it as perp because writing out perpendicular all the time is a lot. Then it is equidistant from the endpoints of the segment. So that's the perpendicular bisector theorem. So what this means for us, we're going to draw a picture of what happens here. If we have a picture like this, where we have a segment, we'll call these points A and B, and then here's our perpendicular bisector. And there's some point on the perpendicular bisector. We're going to call that point P. So if we have a picture like this, then kind of drawing that same picture here, but adding something to it. Wow, that's not very equidistant looking, but doing our best here. Then what that tells me is that point P is the same distance to B as it is to A. Yeah. AP is equal to BP. So if a point is on this line here, it's the same distance from that point to point A as it is to point B. That's what that theorem is telling us. So you'll notice today there's going to be a lot of things that are equal. We're going to be setting things equal to each other. So if this point's on the perpendicular bisector, if this distance is 7, then this distance would also be 7. Stuff like that. Okay. Then we have the converse of the perpendicular bisector theorem, which is going to be the same thing, just switched around. So instead of if a point is on the perpendicular bisector, then it's equidistant from the endpoints of the segment, it's going to be if it's equidistant from the endpoints of the segment, then it's on the perpendicular bisector. So the picture that we get for this one instead, since I think the picture is a little bit more helpful, we're going to draw the picture first. If we have a segment AB and some point P out here, that's the same distance to A as it is to B. So if we have something like that going on, then that means that if I draw the perpendicular bisector to this segment, it's going to go through point P. So it just switches it around. So we're saying if AP, not B, is equal to BP, then this happens. It's on the perpendicular bisector. Okay. So now we got to look at some kind of problems that we'll see when we knowing what the perpendicular bisector theorem says and does. but I'll leave this for a sec, let everyone finish writing, and then we'll do some examples. Okay, example time. Okay, first example. We're going to be given this picture. So this is what we're given in the picture. And we want to know, what is the length of RT? All right, Caleb thinks it's 16. I agree with Caleb, because we can see that this line right here is the perpendicular bisector. So since we know that this is perpendicular and that it cuts this segment in half, that means that since R is on the perpendicular bisector, it's the same distance to S as it is to T. So that means that this would be 16 for our answer. So a lot of the problems that we see today are going to be very simple like this, where you're just deciding what it's equal to. So if you felt like that one was simple and easy, that's great. If you didn't, that's okay. We're going to do another one. Second example. All right, for this one, we get a different picture going. All right, here's our other picture. So we've got this point C is the same distance to A as it is to B. We know this distance is 4. We know these two distances are the same. We know this line is the perpendicular bisector. And we want to know, what is the length of AB? Well, if we know that this distance here is 2.5, then this distance here will also be 2.5, since this is the perpendicular bisector and it cuts this into two equal pieces. So if these are both 2.5, then AB, yeah, is going to be 5. Awesome, Adon. Okay. So those are kind of the two basic cases of the problem. Then we'll have one more type where we bust out the algebra, since that's another thing we love to do in geometry class. Get the algebra going here. So one last type of problem here. before we can talk about angle bisectors real quick and then get out of here. So for this one, (3x plus 1, 5x minus 3), and we want to know the length of hj. Okay. So, like I said, kind of at the beginning here, we are going to be setting a lot of things equal with this concept. So, as we might suspect, the only two things we really have to set equal are here for this problem. And Kayla is very excited about putting the algebra into the geometry. So we've got a perpendicular bisector going on. We know that because it's got the perpendicular marking and it's got the bisector marking of cutting that segment in half. So that means that h is the same distance to j as it is to k. So that means we're going to take these two things and set them equal to each other. So 3x plus 1 equals 5x minus 3. And so then, let's see, I might subtract 3x from both sides to get 2x minus 3 over here. Add 3 to both sides to get 4 equals 2x. Divide by 2 on both sides to get x equals 2. And that's going to be part of our answer, but not the whole answer, because we were not asked what x is equal to. We were asked what hj is equal to. So that means we need to take that 2 and plug it back in right there. So 3 times 2 plus 1 is, going to give us 7. So hj is 7, and that is our answer there. All right. 7's a lucky number. Oh, good. Don't put answer to all, or 7 to all the answers on the homework, though. Although that would be funny if I made a homework assignment where all the answers were 7. Wonder if that would freak anybody out. Should try that sometime. Anyway, that would be mean. Okay. Any questions with any of those three? Any numbers we're not sure where they came from? Any steps we're not sure how they happened or why they happened? Or anything we need to go back to? All right. So the last thing we're going to do today is talk about angle bisectors now. So we've got the perpendicular bisector theorem, moving along to the angle bisector theorem as well. So, let's see, I think I will do it on a different piece of paper. All righty. So, just like we had on the perpendicular bisector theorem, remembering, first of all, that an angle bisector divides an angle into two equal angles. So that's the first thing we need to remember here. And then we've got the angle bisector theorem. Okay, so an angle bisector theorem says if a point is on the angle bisector, then it is equidistant from the sides of the angle. Okay. So if a point is on the angle bisector, then it is equidistant from the sides of the angle. And just like we did with the perpendicular bisector theorem, we're going to draw a picture of what's going on to help us understand a little bit. So if, let's say we've got an angle, we'll call it angle A. And then we have a bisector on angle A. So it cuts the angle in half. We can clearly see that it's doing that because these two angles are equal. And we've got some point, P, on that angle bisector. Then, drawing that same picture, we have angle A. We have the bisector. We have point P on the bisector. So if that is all the case, then we know that P is the same distance to this side of the angle as it is to this side of the angle. And also, when we're measuring distances from a point to a line, or a point to a ray, or a point to anything, the shortest distance is what we consider the distance from a point to a line is the perpendicular distance. So if I go from this point to this ray right here, and I want to find the distance, my distance is going to be the length of the segment that is perpendicular to what I'm going to. So this is what distance is going to look like. So we can say that this distance is the same as this distance here. And so for any point along this angle bisector, the distance from that point to either ray on the sides of the angle is going to be the same. Okay, so that's the angle bisector theorem itself. Then we also need the converse of that theorem, just like we did with the converse of the perpendicular bisector theorem. And it's going to be the same thing. We're just reversing the order. So instead of saying if a point is on the bisector, then it's equidistant, we're going to say if a point is equidistant from the sides, then it must be on the angle bisector. And for this one, again, I'm just going to do a picture instead of writing out the whole thing, since the most important one is the theorem itself. The converse is also important, but I like the pictures for understanding. Okay, so what's going on in this case would be if I've got an angle, call it angle A, and there's some point out here inside the angle somewhere, we'll call it point P. If that point is equidistant from both sides of the angle, then with the same picture going here, then if I was going to draw the angle bisector, it would go through point P. So it's saying the same thing, just in the reverse order. Okay. So when we go through examples, if we see something where we have a picture like this, where we know that these two distances are the same, then I automatically know that these two angles are the same. If I see something where these two angles are the same, then I automatically know that these two distances are the same. So again, a lot of setting things equal. But I'll leave that for a moment, let everyone finish drawing. And then we're going to do a couple of examples. Okay. So first example here. We've got an angle going on. And let's see, we've got an angle bisector going on. And we want to know, what is the length of segment EH? And they might put on some other extra measures to fool you, like, this is 18 or something like that. So when we look at this one, we know that because this is an angle bisector, then this point is the same distance to each of these sides of the angle. So if this is 23, then this is also 23, so EH would be 23. And again, just like we saw with the perpendicular bisector stuff, that's kind of the simplest case. The second example is going to be another case that's one of the simpler cases, but it's kind of the reverse. It involves the converse of the perpendicular, not perpendicular, angle bisector theorem. So on this one, for our second example, we're going to have a point out here. That is 7.5 units from either side of the angle. And we know that this angle here is 26 degrees. And we want to know what is the measure of angle QRS. Okay. So this is going to be a lot like that second one on the perpendicular bisectors, where we end up with like taking two pieces and putting them together, because if this is if t is the same distance from both of these, then we know that this is an angle bisector. Shocking, I know, seeing this is a section about angle bisectors. So that means that this angle is the same as this angle, so they would both be 26. So if they are both 26, the only thing that we really have to pay attention to, because this is what trips people up, is what angle are we asked for? We are not asked for angle TRS. We want to know what is angle QRS, which is the whole enchilada. So that means we need to add them together, 26 and 26. to give us 52 degrees for the whole entire thing. Okay, so that one, or that kind of problem, the thing that trips people up the most, again, is not paying attention to what they've been asked for. So make sure you look and double check what you're supposed to be finding. Okay, so there's the first two, and just like with the perpendicular bisectors, we are also going to toss some algebra into this for our last example here. So let's get going with some algebra. Oh, we'll use green again. Okay, so on this one, here's our picture. Z, W, Y, X. We're told that this angle is 2x plus 5, and that this angle is 4x minus 25. And we want to solve for x. Oh, and we're also told that these are the same distance. Okay. So looking at this new picture, since we know that these two things are the same distance, we know that that makes this the angle bisector. So, since that's the case, if that's an angle bisector, these two angles are equal to each other. So we can set them equal. Again, when in doubt for this unit, set things equal. We have 2x plus 5 plus 4x minus 25 equals. Or, gosh, just kidding. I've got adding things together on the brain for some reason. 2x plus 5 equals 4x minus 25. Dear goodness. All right. So, since these two angles are equal, since this is an angle bisector, we set them equal. And then we solve for x, and then we should be good to go. Because on this one, all we were asked to do is solve for x. So again, make sure you pay attention to what you've been asked for, in case you need to go back and plug x back in. Okay. So here we go. Subtracting 2x from both sides is probably what I would do first. But you can do it whichever way you'd like. So we get 5 equals 2x minus 25. Then I'd add 25 to both sides to get 30 equals 2x. Get it on up. Then dividing by 2 on both sides, we get 15 for x. Okay. And that's our final answer. If you were asked to figure out like an angle or something like that, like if you wanted to know what angle WXZ is, you could always plug it back in and find the angle. But this time we didn't have to. Okay. So looking at all three of those examples, any numbers we're not sure where they came from, any steps we're not sure how they happened or why they happened, or anything that we would like to go back to. Okay. Then, this is the part where we get to take a look at the homework together and get started there. If you haven't logged into Big Ideas recently, you might want to go to Clever and start by logging into Big Ideas. But I'm going to post in Google Classroom the assignment, and then we'll kind of go from there. Okay. So if you go to Google Classroom and you refresh the page, you should see the 6.1 Day 1 assignment. So you can click this link and it'll take you to Big Ideas, but it'll probably also ask you to log in. So make sure you log in with Clever. If that doesn't work from this link, you might have to go through the Symbaloo page and click on Clever there, and then click on Big Ideas and go to Assignments. So just be aware that that's something that could happen. But if we click on it, it should take us to this assignment if we're all logged in and good to go. And it's going to ask for things like find the measure of angle ABD. Note that on this assignment, you can navigate here. There are 9 questions. So not too many today. Also notice that there's a check answer feature down here. So if you have not been familiar with using the check answer feature, if you type in an answer, like 12 or something, or 7, if you're Caleb, and it says that it is wrong because the answer is not 12, you can try again. And you can try again up to 4 times. After 4 times, you can keep trying. It's just not going to tell you if you are right or wrong. So use your chances wisely. If you're on your last attempt or something, maybe wait and ask that question in class, because that might be an indicator that we're missing something. So looking at this, we notice this is an angle bisector problem because we've got, 1, we have angles going on. And 2, we notice that this point is the same distance to both sides of the angle. So that means that this is the bisector. And since we're looking for ABD, someone in the chat, what's the measure of angle ABD going to be? There we go. Thanks, Marissa. We are getting 20. Nice job, Alex and Jamie as well. 20 should be our answer. And we check it and we got it right. All right, so that's how these ones are going to work. The second one is similar, except it's with perpendicular bisector this time instead, because we have less angle stuff going on and more segment stuff going on, and we've got this perpendicular 90-degree angle going here. And we notice that these are both 3.6, so that means it's the bisector. And we're looking for GH. So again, someone in the chat, what's GH going to be? All right, thanks, David. Thanks, Marissa. It is going to be 4.6. Because this distance is 4.6, this one will also be 4.6. Okay, so most of your problems are going to look a lot like this today. Sometimes they'll have a little bit of algebra tossed in for fun. But that's today's assignment. The other thing we want to do today is do the 10 things Google form. So just as kind of another getting to know you guys thing, especially if I haven't had you before in class, this is a Google form. You get to tell me 10 things about yourself. If you had me a previous quarter and you've already done this form before, tell me 10 new things. They can be about you as a learner, as a person, how you feel about math, things that would help me be a better teacher for you, whatever you would like to tell me. They can be serious or not so serious, but there must be 10. And these things will not be shared with the rest of the class. It's just for me. So instead of our usual exit ticket, that's what we're doing today, is the 10 things Google form. All right. Also, let's see, just in general on the Big Ideas assignment, make sure you use the check answer feature. And then if you have questions, you can ask them in office hours. You can ask them right after I dismiss the class. You can ask them in class tomorrow. But yeah, so those are our 2 to-do items today. Big Ideas, 10 things Google form. Any questions before we get to work?